part here is about the product moment correlation. Now, product moment correlation is just a measure of how well two variables are correlated to each other. Okay, it's just a measure. So product moment correlation is what the question wants you to find. Okay, so I put down here 7 different cases. Hey, if X and Y, this one seldom happen. So these are incidental. The X on Y and Y on X are both the same line. Then you have a perfect positive correlation. Okay, most of the time you are going to get something like this. R is equals to 0.8 or maybe even 0.995, things like that. Then you say that there is a strong and positive correlation. What does it mean? When X increases, Y also increases. Okay, but if the R is like 0.4, then you say there's a weak positive correlation. Okay, so the other end of the spectrum, if R is like negative 0.9, then you say there's a strong negative correlation. As well as if you have a R which is like negative 0.4, then you say that there's a weak, okay, correlation. So it's about understanding how to explain when you have your R. Your R, which is the product moment correlation, will always be between negative 1 to 1, where the closer you are to negative 1, the closer you are to 1, right, is better for you. Okay, it's better for you. Over here are some of the explanation that you are supposed to say that, hey, when you are positively correlated, okay, they form a strong positive correlation. Yeah, or a strong negative correlation. As long as, so for example, your R is like 0.995. Yeah, strong positive correlation. Your R is equals to negative 0.9. Strong negative correlation. We are looking for these two types of variables. Okay, we want the variables to be correlated to each other. That means when one will affect each other very well. Okay, now how to find the product moment correlation? All you need to do is, okay, I'm going to use this example so that you can remember the steps again of keying in data. First, go to memory and clear all lists and press enter. Okay, go to stat and then go to edit. Now key in everything is that is X for L1, 2, 3, 3, 4, 4, 4. Okay, and then L2 is for Y, 1.5, 2, 3, 3, 3.5, 4, 4. Make sure you press enter for the last variable. Okay, some students didn't press enter over here and then the value is not entered. Okay, second function, quit first. Now you go to mode, you go to this statistic diagnostics and make sure you on it. Okay, make sure you on it. To find the product moment correlation is the same place as going to generate your regression lines. Okay, so I go and calculate the regression line. My X list is L1. Second function 1 gives me L1. Second function 2 gives me L2. I go and press calculate. And here you see the difference between now and just now is, other than the correlation line that comes out, there's a R square as well as a R. Okay, so what are we actually looking at? We are more interested in the R. R square is like, it will take away the negative values. Okay, so we are looking at the R. You just need to write down R equals to what and explain, hey, there is a strong positive correlation between X and Y. Okay, so in this part, correlation, so rather the product moment correlation is just a measure of how well two variables are correlated with each other. We are looking for strong positive correlation or strong negative correlation. Okay, all you need to do is to explain whether there's a strong positive or strong negative correlation between the two variables.